So let's jump in. Again, this isn't a bit counting. We're not going to do any subnetting here, but let's actually just talk about what the anatomy of an IPv6 address is. Most of the time when we're working with this today, it's because we're doing a if config or we're doing a NS lookup or something. We're getting these values back. So what do these mean? So again, it's 128 bit, very, very long number, broken into little quads of numbers. Each one of those is called a nibble. And these IPv6 addresses can be shortened once by removing sets of leading zeros. So we can take that set of three chunks of zeros, there's three nibbles of zeros, and compress those into that single double red colon there. So just bear in mind, we can only do that once per address, because if we've got two sets of zeros here, two sets of zeros here, and we compress them both, we don't know whether it's 1 and 3 or 3 and 1 or 2 and 2. So again, we can only do that once within an IPv6 address. Oops. Further, we can shorten it by removing the leading zeros from the nibbles, shorten that up. So that IP address, what you see in blue, is really what you're going to get in terms of if you're doing a ifconfig or if you're doing a NS lookup. So we can actually add all that stuff back in by adding the additional zeros to complete the address or adding in the leading zeros. So a little bit different. So you're going to see this in kind of a mark notation versus that full IP address and subnet mask like you would see in IPv4. Now, talking about subnet mask, the IP subnet mask, there is no 255 dot whatever. It's all just slash notation, which is nice, kind of simplifies that. And these slashes typically are going to exist at a break in a nibble. So where you see those colons is where we're going to break that out. So if you think about this, the first break is really a ton of addresses. And when we look at the addresses that are handed out, if you were to call your ISP and say, "Hey, I want a IPv6 block," this would have been a great quiz question. But how many addresses, oops, do you get? Well, typically for business, you get a slash 48, and for personal, you get a slash 64. Think, wow, that's quite a lot of addresses. Well, at the end of the day, slash 64 is more IP addresses than the entirety of the IPv4 space. So when you ask for IPv6 for your home, you are getting in excess of what the entire IPv4 space for the planet has. So you might say, hey, why do we do this? Literally, again, the space is so massive that when we start looking at it, the IPv4 space fits in just the 16 bits here at the end of this address. So we have all this extra address space. It might seem super wasteful, but there are a lot of advantages to this. Um, this bullet says, mobility and IT friendly. Really, this just talks about the early adopters. I don't think in 1998 they really went and said, hey, every person with a cell phone, everybody's going to have a mobile device or 10 mobile devices, and everyone's going to need a public IP. I don't think they quite saw that through, but the people who are deploying IPv6 now are really the large scale mobile providers, IoT environments, and just devices or environments, tens of thousands of devices. That's where we really see the biggest impact, as well as the early adopters. In IPv6, because of this routing space, we talked about these huge, huge subnets. Because there are fewer subnets routing to more hosts, it's more efficient in the routing tables, right? There's less entries in the routing tables to get that across there. And because every device has a unique IP address in the whole space, it's all public. We don't have to worry about, oh, that's a private or that's public, or we have to NAT it, or we get 20,000 IP addresses and we've only got 50 public IP addresses. So really removes the need for NAT again, taking down that load on our layer 3 devices. On top of that, we've got a simplified header format. So we have a 40-bit fixed header, or sorry, 40-byte fixed header versus a 20 to 60-byte dynamic header. We've got options in the header as well that are only present when they're used. So again, we're just really trying to streamline and optimize the traffic with IPsec also built in. And again, on the LAN side, we talk about some kind of benefits on the WAN side with optimizing routing. On the LAN side, again, we're removing a lot of that network chatter from reducing our ARP traffic, as well as, again, bringing in that auto configuration for that IP space. So again, there's benefits on both sides on the LAN and WAN from an IPv6 versus IPv4 standpoint. And when answering the question, should I care? I mean, I think the answer is, what are your business drivers? If you're going to have tons and tons of devices, absolutely, but that's not most of us. If you're writing applications that are going to go to the cloud, most hyperscalers are really going to strongly prefer IPv6 ready apps because that's where their infrastructure is going to be built out on. And if you're future proofing for IPv4 scarcity, bringing higher costs, then that's another reason to roll out IPv6. So one of the things that I'd be curious about, though, is if we're moving more to IPv6 and there's more IPv4 being released back into the pool, how are they going to handle that? Are we going to have this resurgence of IPv4? I would wager not, because I think that's also going to continue to drive the cost down on IPv4. People get more comfortable with IPv6. So I think it's going to automatically balance itself as we kind of continue on that trajectory. So for your own organization, what are some practical steps you could take? So first of all, you're going to audit your current infrastructure, right? You're going to find out what applications are IPv6 compliant and which ones aren't. You're going to find out which network devices are IPv6 compliant, which ones aren't. This is your switches, routers, access points, etc. So this could be all of your IoT devices as well. Everything on your network, you want to know if it's IPv6 compatible. You're going to do the same thing with all of your hardware and your vendors. Find out, hey, does this web vendor use IPv6 at their end? Does my ISP use IPv6? Do I have IPv6 compatible drivers on all my devices? So again, we're just creating a full audit to get a picture of where we are in our own readiness. Then we're going to enable dual stack where we can. Great places to do this are on internet connected segments. Again, test this out before we blow it out. But those devices are going to benefit from the optimized routing on the internet. And also think about doing things like setting up an internal network where you're using IPv6. Maybe you're setting up some segments and you're routing that out and really getting familiar with that technology from a routing firewall ruling standpoint. And then, start training your teams on IPv6 fundamentals. I love the classroom because I love to poll people as I go through. I would say, hey, how many people have trained their teams or even talked or, said, hey, go out and start reading about IPv6 and being familiar. I'd really love to know how much you guys are leveraging that. And then really the deal here is ignore it at your own risk. At some point, you're going to need to move to IPv6. It's going to make more sense than staying on a legacy technology of IPv4. And my encouragement is just to become very familiar with it at this point in a test environment so that when it does come and you need to start rolling out IPv6 and it becomes more of a business standard versus a business exception, then you're more ready for that. Because the reality is it's not a matter of if, but when that actually comes up. So IPv6 is mature and inevitable. Adoption is uneven, but it's accelerating. That graph doesn't really show us that. It looks like it's pretty steady state to me. But plan now, do dual stack, audit your environment, get your staff trained up to some degree, and then get ready for the win because it's coming.